there that we're going to use. This is kind of a heavy section as far as the different stuff that's involved in this. Okay, so the first thing that we're going to talk about is dealing with the sign or dealing with the trig ratios, but in terms of a circle. Okay, so just so that you are aware of it, the sine of theta is going to be equal to y over r. The cosine of theta is going to be x over r. And I'm going to explain what those numbers are in just a second. And the tangent is y over x, as long as x does not equal 0. Now that x does not equal 0 is more of a notation thing, just meaning, hey, we can't divide by 0. Now, what's going to happen is the x and the y are ordered pairs. Okay? So when it says the y and the x up there, that's nothing more than me giving you an ordered pair. So if I give you the ordered pair of 2, 4, 2 is your x, y is your 4. That's what will go in those spots. Okay? Now, as far as the other ones go, what do you think cosecant is?
R over y.
R over y. What do you think the secant is?
R over x.
R over x. And the cotangent? X over y, as long as y is not equal to 0. Okay? Now, just so that you can see where they're all at, I know that this is going to be kind of small on here, but in my triangle or in my circle type things, here's what's going to happen is if I give you, let's say I give you this ordered pair right there, and we draw that through there. That ordered pair is at the point x, y. This line, or that part right here, would be the theta. And this part from here to there, that's your radius. Okay? So here's what ends up looking like once I change the color a little bit. Your x and your y, your x goes here, your y goes there. It makes a right triangle. So therefore we can use the sine, cosine, tangent. What's the r in this case? It's actually the c, or the hypotenuse, every time. So how would you find the r if you didn't know it? A squared plus b squared equals c squared. Or in this case, x squared plus y squared equals r squared. Okay, you might want to have that down too. X squared plus y squared equals r squared. Okay? Everybody got that part down? All right. McKenna, would you give me any ordered pair that you want? Negative square root of 11?
Yeah.
Where'd you come up with that one? Cheater. Okay, so here's what it's going to say. It's going to say, let this ordered pair be a point on the terminal side of an angle in standard position. Evaluate the 6 trig functions of theta. So first thing that I need to know is, let's find the r. I know the x, I know the y, I don't know the r. So I'm going to take 5 squared plus negative root 11 squared equals r squared. What's 5 squared? 25. What's negative root 11 squared? 11. Because the two negatives would make it a positive, and the square root of 11 squared is just 11. So, good job. What's 25 plus 11? 36. Now, normally, because you guys have been in this class all year, when you square root stuff like that, shouldn't you get plus or minus? However, why do I just write the plus down for this? I'm just dealing with distance. So therefore, I can only have the positive. So when I square root that, what's the square root of 36? 6. So I know my radius. Now it's time to come up with the 6 different ratios based on the stuff I just gave you. Okay? So sine. The sine of theta was the y coordinate over the r. What's the y coordinate? Negative the square root of 11 over what's the radius? 6. Cosine was the x coordinate over the r. What's the x coordinate? 5 over the r, which is 6. The tangent is the y over the x. What's the y coordinate? Negative square root of 11 over the r, which is, or the x, which is 5. Now it's time to flip. Cosecant. If I flip this one over, what do I get? 6 over negative root 11. But I can't have that. So I end up with negative 6 root 11 over 11. Oops. That's not the one I wanted to put that on. The secant. No, it's still a negative. So if you would have did it this way, no, if you would have taken and multiplied by negative root 11 on the bottom, then you would have also had to do it to the top. So the negative still would have been in there somewhere. The secant, flipping the cosine over, what do I get? 6/5. And the cotangent. When I flip over negative 11, or negative root 11 over 5, what do I get? It's kind of like the secant, right? There. How's that? Okay, so kind of like the cosecant, except for this time instead of a 6, I have a 5. So a negative 5 root 11 over 11. And because I asked McKenna, because she knew what the assignment was already, because she was supposed to be gone and this is what I was going to give you Friday, that one is in your assignment. So the first thing you need to do is you need to find R. And then after that, you just plug in the numbers just like you did the last couple of days. Okay? All right, then from there, we're going to start talking about the unit circle. Jackie, would you hold yours up? And Jackie took my advice. Keep holding it up. Jackie took my advice and printed off the unit circle. Again, if you want that obviously is never going to fit on a note card. Okay? By all means, find a unit circle, print one out so that you have one. Okay? Just type in, Google search, unit circle. There's, I don't know how many thousands of pictures you could look. Print one out. I don't expect you to memorize that stuff, but it will end up happening. In the unit circle, just so that you guys know, the reason why they refer to it as the unit circle is that your radius is always going to be 1. So in this case, when we're dealing with the sine curve, for instance, if we had the sine was equal to y over r, what's the radius for a unit circle? 1. So the sine is going to be nothing more than y divided by 1, or just y. Whatever that y coordinate happened to be. Same thing with your cosine. Ooh, can't write cosine apparently. The cosine was x over r. But if your radius is always going to be 1, what's your cosine just going to be? X. So if I give you an ordered pair and I tell you it's on the unit circle, then if I want to find the sine and the cosine, it's whatever the x is and whatever the y is. That's all it happens. That's all that happens. Anytime you're dealing with a unit circle, you're dealing with a radius of 1. The first first problem that McKenna picked was not on the unit circle. It never said it was on the unit circle. But if it says, I'm on the unit circle, you use the unit circle to evaluate the 6 trig functions, it tells you that you're using the unit circle. So therefore that means that your radius is always 1. Then we need to know what the x and the y is. A lot of times what they'll do for that one is they'll say, evaluate or use the unit circle to evaluate the 6 trig functions of theta equaling 270 degrees. Now I'm more of a picture person, so I'm going to draw where 270 should be. 90, 180, 270 is right here. That's the terminal side. Is that bottom part of that part? So, if I tell you that the radius is 1, right? Didn't we know if it was a unit circle, isn't the radius always 1? How far down is that? 1. Very good. So the ordered pair is at 0, -1. That's the ordered pair for where that's at. Okay, now that we have that established, what would it be if I were to stop here? -1, 0, right? If I would have stopped here. If I would have stopped 1 high, that would have been 0, 1. What if I would have went 1 full rotation all the way to here? That would have been at 1, 0. Okay? So if that happens, if they fall on those lines and they are dealing with the unit circle, all it is 0 and 1. It's just a matter of where that spot goes. Now, coming up with the 6 different trig ratios. The sine ratio, as we just denoted, was y. What's the y coordinate? -1. Cosine was equal to the x coordinate. What's the x? 0. Tangent is equal to the y over the x, does it not? Remember that one? But we got a problem. X equals 0, and didn't we say it cannot equal it? If you put the y over the x, you're going to have -1 divided by 0. Can you do that? No. So for this particular part right there, that's actually UND, which is short for undefined in this case. Okay? Not where some of you guys are going to go off to college. Okay? But when it's when you're going to divide by 0, that's not possible. Okay, now let's find the reciprocals of those. The cosecant. If I put this over 1 like it's intended to, what's the reciprocal of the sine? -1 still. Good. If I do the secant, what's the reciprocal of 0? Not 0. If I put this over 1 and I flip it over, I'm taking 1 divided by 0. Can you break that into 0 equal pieces? No. So what is it? UND. It's undefined. Then as far as the cotangent goes, remember that one was the y over, now it's the x over the y, so what's the x coordinate? Over -1? What's 0 divided by -1? No. No. 0. 0 divided by a number is 0. Now those particular problems, just so that you guys know, did I have to do a whole lot of math in order to figure that out? No. Did I put the x and the y and the r in just like I did on the one for McKenna? Yeah. Except for my numbers are going to be like 1s and 0s. It's not going to be anything else. If it's dealing with the unit circle, it'll go a lot faster. Okay? Now, the next thing is dealing with reference angles. Okay? So as far as a reference angle goes, if I give you an angle of negative 130 degrees, and like you guys did for me last week, how would you draw the angle of negative 130? Huh? Clockwise? How far? Tell me when to stop. Okay? Why did you stop there? Okay? I want you to ask, I want to know something. I want to know, if I made that triangle there, how big is that angle? How did you get that? That's a 50-degree angle. Awesome. Okay? That's what a reference angle is. A reference angle is the angle that is formed after you draw yours, the angle that is formed the fastest way to get back to the x-axis. That's the fastest way. I don't want to make this thing go all the way back here, 130 degrees. Yuck. I'd rather deal with the 50. It's a little bit smaller. What line?
The line was straight down.
The red one?
Yeah.
This one here? I made it. I made it into a triangle.
Does it matter what the line is?
No. Okay? Alright. Let me give you another one like that. What if I give you 5 pi over 3? Again, I think like some of you guys, I'm not very good at drawing my radian measures. So what would you have to maybe do in order to figure out where that angle should go? Convert it to degrees. If I want to convert that to degrees, I got to take 180 over pi. I need to get rid of the pi's. What's 5 times 180? 900 divided by 3? 300. I'm drawing a 300-degree angle. That's what I'm drawing. Which way does it move? Counter or clock? Counter. You tell me when to stop. Oh, I heard someone say stop. Okay? Which? This is what I need to know. The reference angle is the angle that it's formed the fastest way possible back to the x-axis, which is this one here. What angle was that I just created? Huh? No, not the other one. 60, right. That's a 60-degree angle that I just formed there. That's your reference angle. Your reference angle is the angle that it takes to make your terminal side go the quickest way back to the x-axis. That's what it is. So when they ask you for what's the reference angle, they're asking you to what's the fastest way possible back to the x-axis. It's not to go back all the way 300. It's to go up 60 more. Okay? Does that make sense how to find that? Do you want me to do another one? Casey says yes. Casey, pick an angle. 70? A 70-degree angle is going to be approximately right in here. Okay. Casey, are you okay with me drawing that in there? Okay, so you know where the angles are supposed to go? Okay. Now, if I drop that straight down, Casey, have you ever done any construction before? Have you ever made a wall? Have you? How do you know if a wall is straight? Okay, one of the things you could use is a level board, even if the board is level. I mean, how do you know, like, if I'm straight down, Have you ever used a tool called a plumb bob? That's what this is doing. Okay? In case you're not sure of what we're talking about. Can I trade you?
Oh, yeah, sure.
That's my numbers.
Okay, thanks.
Okay, what we're talking about is in construction, carpenters use, in order to make walls straight, like where all these beams and stuff are, they use a tool called a plumb bob, which is basically a string with a weight attached to the bottom of it. And they attach it, they measure over the top, however far studs are supposed to be, which you probably don't need to know. And then what they do is that they drop the plumb bob straight down. Because the weight will eventually, as it stops, create a 90-degree corner. Okay? It's a lot faster than measuring, because what if you're off in your measurements? Right? Could have not straight walls, which is not a good sign. So this is acting like your plumb bob. Does that make sense? Okay? So what I want to know then now, Casey, is how big is this angle right there? Because 20 would make it actually go back to this way. How big did the angle that we just made? Yeah. It makes the 70. It's always this angle where the vertex is right at the origin. Okay, so when you told me a 70-degree angle, we actually made, the reference angle is 70. Because it's less than that 90. If it's less than that 90, it's the angle that it happened to be. If it's greater than 90, it's the one that makes it back to 180. Okay? What happens if it's 180? Then you're dealing with the unit circle stuff. Then you wouldn't necessarily have a reference angle because you'd have this thing right here. You'd have this straight line right there. They're 0. Okay? So, finding reference angles, are you guys okay? All right. Now, the last type of thing that is involved in here is they're going to give you stuff like this. It says, evaluate the tangent of negative 240 degrees. So first thing I'm going to do, because I like to have a picture, I want to draw negative 240. Where's negative 240 at? Which way do I move? Clockwise. 90, 180, 240 is about here. Now, the fastest way I can get back to the x-axis is dropping it straight down this way. That's the fastest I can get there. Everybody okay with that? Now, what angle did I just make for the reference angle? 60. Hey, Denise, guess what we have? We have a thing called a 30, 60, 90 triangle. Why do you think I revisited that last week? Because we're going to use it again. Okay? So on this particular thing then, this one happens to be the short side, this one's the hypotenuse, and this one is the adjacent side, or the opposite side. If we want the tangent, remember we're dealing with opposite over adjacent. If we say that this is the unit circle, and we say that that's 1, what's half of 1? 0.5 or 1/2. And then if I take that times root 3, I get 1/2 root 3, or the square root of 3 over 2. So what's the opposite side from the 60? Root 3 over 2. Divided by, what's the adjacent side? 1/2.
2 come from?
Can you have a fraction inside of a fraction like that? No. How do you get rid of it? Multiply by its reciprocal. When I multiply the bottom by the reciprocal, what else do I have to do, Fallon? Yeah. And if I do that, these 2's end up canceling out. That whole bottom goes gonzo. And what do I get? I get the square root of 3. Now, the one thing that you need to be careful about is that right now you'd be half right. You have the number. The square root of 3 is okay. It's just, it's supposed to be negative. Why is it supposed to be negative? Because it's in quadrant number 2. Remember how these were always broken out into like quadrant 1, quadrant 2, quadrant 3, and quadrant 4? Do you remember that from way back in the days when you guys were doing this stuff? In this particular case, if I wanted to get to where this one's at, I'd have to go negative on the x, positive on the y. So that should mean that if I'm a tangent, I should be a negative because of the fact that I would have had one negative and one positive. Does that make sense? On the bottom of page 868, they give you what all the signs should be for the different ratios. If you want to write that down, be my guest. And that would be something, maybe once you guys print out your unit circles, maybe that's something that you put on the back side of it. Or if you have room on the front side, you put it on the front side. For this particular chapter and whatnot, I'm probably going to give you more than just a note card. Because unless you're Lexi, which I don't know if you guys have ever seen her note cards, but you guys are not going to be able to fit everything on one note card. And I say that because her handwriting is almost to the point where I need a magnifying glass just to read it. Okay? But I'm probably going to give you more. So once you get the unit circle, that might be a chart that would be handy. Maybe put that on the back side of it. Okay? So, what's going to end up happening, did I give you all the way to 30, right? Is that what it happened, okay? Is, what if I gave you the cosine of 7 pi over 4 and asked you to evaluate it? Now, the one thing I hope that you guys are aware of with this, have you guys noticed on the last problem, did I ask for all 6 of them? No. I'm starting to wean you down to just one of them. I just want one of them. I just want the cosine. Okay? So first of all, because we're not very good at where we're supposed to go, I'm going to multiply that by 180 over pi. I need to know the angle. So the pi's cancel out. 7 times 180 divided by 4 is what? Huh? What? 315. So really I'm finding the cosine of 315 degrees. Huh? It's 180. Maybe you wrote 0 instead of the 8. Okay, so 315. Where is it supposed to go? I'll help you out. It should go right about there. What's the reference angle? .45. How'd you get that, Denise? 360 minus 315, because 360 would be one full rotation. 315 was all the way this way. That's a 45 degree angle, which means the other triangle that we had, the 45, 45, 90, which means your x and your y should be the same answer this time, shouldn't it? So in this particular case, if my radius is 1, remember how that worked out where this was x, and this was x times root 2. So how do you work backwards? So So I'm going to take 1 and divide it by root 2, which ends up being root like this. The square root of 2 over 2. That's your x and your y for that particular problem. All I'm looking for and interested in, you guys, for this one is the cosine. The cosine is the adjacent side over the hypotenuse. How big is the adjacent side? 2 root 2 over the hypotenuse, which is 1. So what's 2 root 2 over 2 divided by 1? Or root 2 over 2. I said it wrong the first time. Now for cosine. Cosine was the x. That's a positive number. The radius is positive, so I should have been a positive. If I would have said sine, I should have been negative, because I would have been down, right? All right. So on page 870 to 871, we're 4 to 30. We'll go multiples of 4. I think I had evens originally on there, McKenna, right? But I'll change it up and give you multiples of 4. Now remember that, Zoe. Multiples of 4.